In this video, we're going to deduce the structure of an unknown molecule C3H6, again, without a relative peak area. Okay, so this one is even simpler than the one we did in the previous video, which just has one singlet, and that is it. Okay, so you've got nothing to work from. So if we just do the table and we put our chemical shift in, you can go to the data sheet here again. You can see 2.1 would be a CH next to a C double bond O. So that kind of gives us a bit of an inkling as to what it might be. But another thing that can happen here is, again, we look up at the top and we go, right, okay, C3H6. So C3H6, so that means we've got CH3s, CH2s, CHs. What divides into C3H6? Well, two CH3s go into C3H6, so that kind of makes sense. So let's look at the peak splitting, the peak area. We know we've got one hydrogen environment, which means we have symmetry, okay, because we've got 6 hydrogens, so we must have symmetry. The singlet means there's nothing on the adjacent carbon, or the hydrogen is on the oxygen. We know the hydrogen is not on the oxygen because we cannot see a singlet peak here that's small. Remember, we usually have a small one like that somewhere around here, usually, okay, which is an alcohol, so it's not likely to be an alcohol. So we think from dividing it into C3H6 that we've got CH3, and we think we've got 2 CH3s. So let's have a look at this as it fits into the normal molecular formula. So if that's the case, and we put 2 of them in there, because C3H6 divided by CH3 is 2 CH3s, okay, we get CO, which then suggests again that this is a ketone. So let's put this all up to the side again, okay, and see if we have that ketone. So we've got 2 CH3s. Okay, there's your CH3, both terminal, which means something must bond to them in the middle, okay, and that is CO. And so what we have is a ketone, okay, and this would be propanone. Okay, just to do a check, that is next to a carbon with no hydrogens on, so would be a singlet. There's a plane of symmetry down the middle here, so these are in the same environment. So this would also be a singlet. Would have a relative peak area. If we did have the relative peak area is 3 for this one and 3 for this, so it would be 6. However, there's no relative peak area because the word relative is used. You have to have more than one peak to have a relative peak area, and there's only one peak in this, okay? Because those hydrogens there, these hydrogens here and here are equivalent to each other because of this symmetry down the centre of the molecule. In this NMR, we have looked for a broad peak with a relative peak area of 1 for the alcohol because we had an oxygen, so that's something you always need to do. And there is your peak that you'd normally see. Now, there's no relative peak area, then the hydrogens must all be equivalent, so we then also looked for symmetry. Okay, knowing that there was no alcohol, we looked at what remained and it was CO, and therefore we saw that it could be a ketone.